All right, so earlier today we looked at the sine law, which again was used for non-right angled triangles. Now we're going to move on to another law that's used for non-right angled triangles, and that's the cosine law. Because essentially, the sine law works for every non-right angled triangle and right triangles. It works for that too. But there's two situations where it does not work. And that's when we need the cosine law. So the first situation that we're going to do today is when you have what's called SAS, side angle side. That is when we're going to use the cosine law. So when you have a side, then the angle, and then the side, that's your given information. You cannot solve it using the sine law. So that is, like I said, there's two scenarios. We're going to do one today, one next class. Now, our cosine law, again, is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Now, again, the A's, the B's, and the C's are just like the sine law. All right, so in this case here, when I look at my angle here, that's angle B, and I have 40 degrees. All right, but again, across from it would be side B, which I don't know. I have this 10. It's across from angle A, so it is side A. Again, just like the sine law or the sine law. There's angle C. Across from it is side C, so side C is a 12. All right, and we are looking to find side B here. So that's our question mark. All right, now, here's the trick of this formula. Is that you see that it says a squared equals b squared plus c squared, keeps going on and on. There's just the a squared on this side of the formula. But I'm trying to find side B. So here's a little trick with this formula so that I don't have to, that when I substitute in, I don't have to rearrange things. I'm going to rewrite this formula because in an effort to get it so that I can solve for B. And here's what I mean by that, is I'm going to switch, because I'm finding side B instead of A, I'm going to switch my A's and B's. And so when I rewrite this formula, because that's what I'm going to do, I'm going to rewrite it, instead of an A squared, well, I want the side B. So I'm going to have B squared over there. But now, like I said, I switched A's and B's, so this B squared becomes an A squared. Because I'm switching A's and B's, because I'm finding side A, or side B, sorry. C squared, again, I'm not touching that. I'm not touching C's, I'm just switching A's and B's. Instead of minus 2bc, I'm going to have minus 2ac. Again, switching the b out for an a. And instead of cosine angle A, well, I'm going to have the cosine of angle B. So now I've rewritten that formula just by switching A's and B's. So now I can just substitute in, and I don't have to do any rearranging at the end. All right, which a lot of people mess up. All right, so now I have my formula, so I can solve for side B here. And so I'm going to substitute in my known info. So I have b squared is equal to a squared. So a is 10. So we have a 10 squared there. C is 12. So I'm going to have a 12 squared. And then I got minus 2ac. So minus 2 times a and times c times the cosine of angle B, which is 40 degrees here. All right, there we go. So I've substituted in all my information. Now I can simplify things. So I have my exponents here following Bedness, right? So I have 10 squared, 10 times 10 is 100. 12 squared, 12 times 12 is 144. So again, following Bedness, I just did my exponents. And you know what? I can get this cos 40 degrees too, because I'm not doing anything there other than just typing it into my calculator. And when I do that, I get 0.77. There we go. So I just changed the way cos 40 look. I just figured it out. Now, again, we got to follow Bedness. This is the mistake. This is where most students make a mistake here with the cosine law, not following Bedness. I have to multiply next. Well, and Bedness is multiplying and dividing. We don't have any. So I'm going to multiply these four numbers here. The 2 times 10 times 12 times 0.77. All right, so here we go. B squared is equal to 100 plus 144. Again, I'm going to multiply those four numbers because Bedness tells me to, and I get 184.8. Now the next step in Bedness is my adding and subtracting. So I'm going to take those numbers and put them together. So I have 100 plus 144 minus 184.8, and I get a 59.2. All right, and then my last step, which is good. You notice everything's getting simpler. That's always key in math. I'm going to square root both sides. All right, and when I square 59.2, again, I would get two answers if you remember from our quadratic unit, but because we're dealing with lengths, I'm only worried about the positive answer in this unit, and so I get positive 7.69, and there we go. All right, so again, we had to rearrange our original formula here so that we can just solve for b, and like I said, because we did that, we don't have to move things around at the end, which again can cause problems. All right, so let's try another kind of an example here. So some different situations I have. All right, so example 2. We get, let's see here, it should say find the missing side. All right, so here's my triangle. I have, okay, I have, this is E, F, and D. All right, and I have 35-degree angle here. I have 23 here and 15 here. All right, so now I want to find the missing side. Now, here's a slight thing that you can do. Is see how our formula here has A's, B's, and C's in it, right? But this is triangle DEF. Well, if I'm trying to find this side, here's what I'm going to do so it works easier with my formula. Instead of calling this triangle DEF, I'm going to put an A here instead. Guess we'll go with a B here. What did I do in my note here? Whoops, I didn't do that in my note. I put a C there. Doesn't matter though. And across this one, I put a B. All right, so I just relabeled my triangle. It doesn't change the triangle, just makes it easier for me to use this formula. And so because I put the A there, that means that's side A. All right, so again, with my newly labeled triangle, I'm just going to write down my givens here. I got my 3 angles, 3 sides. All right, so again, side A is what I'm trying to find here. My new label, that means C23 is across from angle C, so that's side C, which makes 15 B because it's across from angle B. And what angle do I have here now? 35 degrees. And again, on a test or quit, or well, I guess a test for us, when you look at the question, you're like, well, it's a non-right angle triangle. Do I use the sine law or the cosine law? Again, this is that one situation. Side, then the angle, then the side. All right? So we are going to use the cosine law, but again, just showed you a trick of relabeling my diagram. I made it that we're going to find side A because now I don't have to rearrange my formula. Right? I have my formula, which is A squared is equal to B squared plus C squared minus 2BC, the cosine of angle A. All right, so once again, I'm going to substitute in my numbers, follow Bedmas, and then get my side A here, which is the missing side. All right, so let's see here. I got A squared. What's B? I got a 15 and a 23 here, so B is 15 squared, or 15 squared there. C is 23, so now I got a 23 squared. Minus 2BC, cosine angle A, so I got minus 2 times 15 times 23, and what was the angle A there? And that's why I write it with givens. 35, so I got cos 35 degrees. All right, so again, just simplifying using Bedman. So I got to do the exponents first. 15 squared, let's see here, I get 225. All right, 23 squared, yikes, I don't have that one in the head. I get 529. All right, so I've done my exponents, so I'm just going to rewrite the rest. Although I can change this cos 35 degrees, that's I can just change the way it looks. because it's just a decimal and it is, let's see here, put in 0.82. There we go. All right, now, again, this is the spot that everyone makes a mistake. You got to follow Benjamin. So I got to multiply my four numbers here first. So again, I got 225 plus 529. All right, minus, multiply all of those four numbers here, and I get 565.8. Now, following Benjamin, I can do my adding and subtracting. All right, so I get a squared. Let's see here, put those numbers together. So I got 225 plus 529 minus 565.8. I get 188.2. All right, and then again, our last step. Take the square root of both sides. And let's see here, it's going to be 14 something, 15 something. We got 13, close. 0.72. And there we go. All right, so again, you can relabel your triangle, right, so that it fits our formula of A's, B's, and C's. All right, now, next up, I'm going to show you something here, our last example. All right, now, let's see, example 3. Is we're going to find side C using the cosine law. Going to be a little bit of a trick, not a trick here. I want to show you something. All right, so here's my triangle. And in fact, I'm going to make it a right triangle. So throw a little, and I'm going to call this A, C, B. So I'm labeling my triangle A, B's, and C's. I got a 12 here, a 5 here, and well, across from angle C would be side C. All right, so there is my triangle. All right, so again, I'm looking at angle, write down my 3 angles, 3 sides. Now, the thing with the sine law and the cosine law, they are used for non-right angle triangles, but they can also be used for right angle triangles. So they work for both. But I'm going to show you something. All right, so I look at my sides here. Across from side A, or angle A is side A, so side A is 5. Across from angle B would be side B, so that's a 12. I don't know what side C is. But I do know the angle across from side C is this 90-degree angle, so C is a 90-degree angle. All right, now, again with our formula, I am trying to find side C. So I am, again, going to rearrange my formula so that I don't have to move things around at the end. So what that means with my formula this time is because I'm trying to find side C, I'm going to switch A's and C's. All right, so instead of an A squared, I'm going to have a C squared. B's I'm not touching, so that's still a B squared there. Plus C squared, so again, I'm switching A's and C's, so it's going to be plus A squared. Then the second part says minus 2BC, so it's going to be minus 2BA, because A's and C's are switching. And of course, the last part, multiplying by cosine angle A, well, I'm going to be multiplying by cosine angle C. All right. So there's our formula. All right, I'm going to substitute in my information. And so B squared here is 12. So I'm going to have a 12 squared. A is 5, so I'm going to have a 5 squared. I don't need those brackets there, get rid of them. All right, and then let's see here. Minus 2 times B times A. So minus 2 times 12. Times 5 and times the cosine of angle C, which is cos 90 degrees. All right. So again, I'm going to do Bedmas. All right. So I got to do my exponents first here. So 12 squared, I just had that. 12 times 12 is 144. 5 squared, I know is 25. And then I got minus 2 times 12 times 5 times the cosine of 90. So again, I'm going to figure that out. And when I put in the cosine of 90 degrees, I actually get 0. All right, so then I get c squared is equal to, let's see here, 144 plus 25. Then I multiply my 4 numbers. Well, 0 times anything is 0, so those 4 numbers is equal to 0, because you multiply any of those by 0, it just keeps multiplying by 0. All right, so I keep going on here now, the adding and subtracting. I get 144 plus 25. Let's see, I got 100, 2 and the 4 is 6, 4 and the 5 is a 9. So I got 169. And just like we've had with the other 2 examples, the last step here is take the square root of both sides. And so the square root of 169 is 13. So we just used the cosine law to solve for a right-angled triangle. Now, here's what really happened. Because we solved using a right-angled triangle, look at this part here. It's 0, which means all of this doesn't count. Here, why don't we just highlight it? So that's 0, which means all this part never counted, which all this part never counted, which means all this part never counted. Watch what happens when I take away the part that doesn't count, because this was a right-angled triangle. What essentially did I use then when you have a look at it? Anybody? What's that formula look like here at the top? C squared is equal to B squared plus A squared. That's right, the old Pythagorean theorem. So here's the key is that when you use the cosine law for a right-angled triangle, it just simplifies down to the Pythagorean theorem. When you use the sine law for a right-angled triangle, it just becomes the sine ratio. So that's just the cosine law and the sine law can be used for right-angled triangles, but essentially they just simplify down to the Pythagorean theorem, or in the sine law case, the sine ratio. That's all that happens. All right, so just a little different, interesting thing there. Again, being able to rearrange that